Okay, welcome to this course, Cryptography and Security. We will start by a simple introduction of the course. So in this course, we will start by a brief introduction, and then we will see together the symmetric encryption. Here we will uh, discover the classical encryption technique, and after that, the well-known data encryption standard and the advanced one. After that, we will see together the asymmetric encryption, and here we will see the public key cryptography and the well-known RSA algorithm. Then we will check the data integrity. Here we investigate the different hash function, the message authentication code, and also how the digital signature is done. We will see the different way to do it. And then we will go into network security and we will see how to achieve key distribution and user authentication and how to have some network access control schemes. So this is typically the content of the course here in semester 9. So I will start in this chapter a brief introduction about the content, and then at each session we will try to have a specific part in order to progress in this course. Okay. So the reference of this course, this is a well-known reference, which is cryptography and network security to William Stalin. It's well known. Okay. You can use it, you can download, you can find also a different edition of this book. It's an interesting book as a reference of this course. And there is another one which is also an interesting one where you have different authentication and access control scheme. You have different practical cryptographic method and tool. It's also an interesting reference. So let's start as an introduction with the basic terminology. For those who was in the cyber community, they are aware about those terminology, but because this course is for all of you, so we should uh, present them completely. So let's start with the plain text. Because we deal with cryptography, so we have what we call plain text, which is the original text, the original message before any decryption. So we say plain text. The ciphertext is the text that we obtain after the encryption. So we have a plain text, we apply an encryption, and we obtain the ciphertext, which is the coded message. And enciphering or encryption is the process to convert from the plain text to the ciphertext. As deciphering or decryption is a reverse process where you restore the plain text from the ciphertext. Okay? So when you cipher, you go from plain text to the ciphertext. When you decipher, so you recover the plain text from the ciphertext. Typically, as a basic terminology, if you want to know what's cryptography, the science of cryptography or the domain of the cryptography, it's the study of encryption. Okay. And here in this course, we will see together different encryption algorithms. So we will study those algorithms. That's why it's cryptography. Another well-known definition, which is the cryptographic system, where are the different schemes used for encryption. We can find also two terms, which are cryptanalysis and cryptology. Cryptanalysis are the technique used to decipher a message. So when we want to try to decipher a message, okay, we call them cryptanalysis. Here we can analyze the security of the techniques in order to see if it's possible to decipher them or not. And the cryptology here, the cryptology is the area of cryptography and the cryptanalysis together, which include both. Okay, so that's what we call science of cryptology. So those are typically the terms that we deal with within this course. Okay, regarding cryptography. So after having the basic terminology, let's see together what are the security concepts. It's well-known three concepts, CIA, which is confidentiality, integrity, and availability. And those are the three important concepts in security. They include the fundamental security objectives for both data and for information and also for computing service. So let's see together what's the confidentiality as a security concept. As a definition, the confidentiality is to preserve authorized restriction on information access and disclosure, to preserve authorized restriction on information access and disclosure, including means for protecting personal privacy and property of information. So the idea here is that if the information are confident, this means that only the authorized person could access to them and could see them. So if you have unauthorized person, they should not access or they should not know the content of the data. So what's the loss of confidentiality? The loss of confidentiality is the unauthorized disclosure of information. So that's why to have a respected or to preserve the confidentiality, so the information should be protected and only authorized person should know them. Okay, so if any unauthorized person or unauthorized access to those data is achieved, this means that we lose the confidentiality. For the integrity, it's another important concept where we should be sure that the information are safe from any modification. So it's guarding against improper information modification or destruction, including ensuring information non-repudiation and authenticity. This means that if we want to transfer, for example, the data from one location to another location, we should be sure that the data will arrive at the destination without any modification, without any destruction, without any addition, and so on. So a loss of integrity is the unauthorized modification or destruction of information. So this is an important concept where if you want to maintain the integrity of the data, so you should be sure that when sending those data, the data are authenticate or with authenticity. This means that there is no modification, no destruction, no addition to those data. As a third concept, which is the availability, here it's very clear that we should ensure timely and reliable access to and use of information. So if you have any data and you store those data somewhere, so those data should be available for your use. This means that if you cannot access to your data, then this is a loss of availability. Okay, so a loss of availability is the disruption of access to or use of information of an information system. So that's why those three concepts are very important concept for security, and we will see them together also in the mechanism and also in the different mechanism that we will see together in future chapters. So we talked about the security concepts, which was confidentiality, integrity, and availability. And now we will see together what are the security services. So as a definition, we can have the ITU definition. What تعرف ال ITU, it's an international telecommunication unit. International Telecommunication Union. There is a section in this union which is telecommunication. T stands for telecommunication. ITU is responsible for a lot of telecommunication standards, and the security also is one of the domain that's of interest for this organization. There is other, if you want, there is other organization or entities that deals with security. For example, you have IETF, which is the Internet Engineering Task Force, you can find also some standards or some proposal regarding to the security. You have also IEEE. You well known IEEE here. It's also you have some standard proposed by IEEE for security and so on. So let's continue with the definitions of the security services. So the security services defined by ITU, which is a recommendation X800, they define a security service as a service that's provided by a protocol layer of communicating open system and that ensure appropriate security of the system or of the data transfer. So this means that you have here a kind of security services that is typically provided by a protocol layer, okay, in order to ensure some, let's say, security of the data transfer. So typically it's related to data transfer. So another definition, which is the request for comment, which is IETF standard. And here in IETF, typically anyone could propose a standard. It could be draft. And when it's okay, it's pass a standard, it should have a number. It will be a RFC, request for comment, and with a certain number. This means that it's adopted. So for RFC, 4949, it provides another definition, which is a pre-processing or communication service that's provided by a system to give a specific kind of protection to system resources. Security services implement security policies and are implemented by security mechanisms. So for IETF, here we consider that if we want to have a security service, it's a way to give a protection for a system or for the data. And in order to do that, you should use some security mechanism according to a predefined security policy. So you have a policy of security, and in order to provide this security service under this policy, you need to have a security mechanism. فإذا انتبهوا صار عندي security policy وعندنا security service وعندنا security mechanism. Security policy is the policy adopted by an establishment or by an organism. We have the security service, which is the service that should be provided according to the security policy. And in order to achieve this security service, we should implement security mechanism. يعني بالآخر عندنا mechanism implemented, security mechanism implemented in order to achieve the security service according to the security policy. So let's see together what are the different security services. Here, one of the important security service is the authentication. So we have a well-known security service in order to authenticate. So this is the assurance that the communicating entity is the ones that's claimed to be. فإذا نتأكد إنه the entity is the right one, okay, as it claims. So peer entity authentication is used typically in association with a logical connection to provide confidence in the identity of the entities connected. And we have also authentication of the data to be sure that we have data origin authentication. And let's say if you have connectionless transfer or something like that, you should provide assurance that the source of received data is as claimed. So that's why we have authentication. This is an important security service. Another security service, which is the access control. And here you should have the service that allow unauthorized or to prevent unauthorized use of a resource. So you have to control who can have access to a resource, under what conditions access can occur, and what those accessing the resource are allowed to do. That's what we call access control. It's also an important security service. You have also data confidentiality. As we said here, this is the protection of data from unauthorized disclosure. You have also traffic flow confidentiality. Here, for example, let's say someone try to analyze the traffic in order to see, for example, if you have a huge traffic or a low traffic. So after monitoring this traffic, it's possible to conclude and to analyze this traffic in order to conclude what type of traffic or what's the, let's say, the service you are using, and in order to prepare or to try to build an attack or something like this. So the fourth service, which is the data integrity, and here also is a service that to ensure that the data are received exactly as sent, so without modification, without alteration, and so on. Okay. So another important service which is the non-repudiation, and here it's an important service that provides protection against denial by one of the entity involved in a communication of having participated in all of a part of the communication. So no one can deny إذا حدا عمل service أو حدا بعت شيء with the non-repudiation service. It's not possible to deny this. ما في ينفي في عندنا proof إنه هو اللي عملها. So that's why non-repudiation is an important security service. And the uh, uh, last one is sorry, the availability is also another security service, and we say here it's a service to be sure that the system or resource is available to be used. And those are the, as we said, the security service, authentication, access control, confidentiality, integrity, non-repudiation, and availability. Those are the services, okay? And we will see together if we want to use those services, how we can implement them. In order to implement them, we need what we call security mechanism. So different security mechanisms are defined in the ITU standard X800. Here we can have enciphering or encryption, digital signature, access control mechanism, data integrity mechanism, authentication exchange mechanism, a traffic padding mechanism, routing control mechanism, notarization mechanism. Those are security mechanisms. Okay. And in order to see together, we will see them in details in the future chapters. Okay. So let's us see together the relation between the security services and the security mechanism. Let's say for example, we have a service that is, for example, uh, to have a kind of data integrity. For example, we need a service of data integrity. Here, for a service of data integrity, it's possible to have mechanism like encryption, and you have digital signature, and also authentication exchange. So here you can have different mechanisms in order to be sure that you achieve this service of data integrity. For example, if you want to have a kind of authentication also, for authentication for peer entity, you have enciphering, digital signature, and also authentication exchange mechanism. So you can use different mechanisms, for example, in order to be sure that you can achieve the security service. For example, if you want to have non-repudiation, here the service that that's used to avoid anyone to deny that he is or she is or it is involved in this communication. So here we need digital signature in addition to a kind of data integrity mechanism. So this is the way to link the security service and to implement them through or using security mechanisms. So this is an interesting table. Okay. And also for non-repudiation, we can use kind of notarization in order to be sure who could provide, for example, a signature or something like this. Okay. So this is really a simple introduction about this course. So in the next chapter, we will start together uh, by the symmetric encryption, and we will see together using in cryptography what are the different dimensions. So we will see together what could be a substitution, what are the transposition, and after that we will see what's the number of keys that could be used. So here we will see symmetric, which is single key or conventional encryption. We will see also asymmetric, which is public key encryption or two keys, and we will see together if we have a block cipher or stream cipher. So we will see those details in next chapters. Okay. So this was a simple introduction about the cryptography and security. So please you should review them. We have several, typically in each chapter we have several exercises that we should do them. And if you have any question, you can send an email or you can send me a message in order to discuss to you online. Okay. So let's move to the second session, which is the symmetric encryption chapter. Okay.